Here, our goal is to calculate the value of x and y. And notice that we have this matrix multiplied by this matrix, and this is equal to this matrix. And so the first thing that we have to do is we're going to multiply this matrix with this matrix. Now, what do we know about this matrix? What do we know about this matrix? What is the order of that matrix? Now, the order of that matrix is 2 by 2. And we know it's a 2 by 2 matrix because it has 2 rows. So we have this row, we have that row, 2 rows and 2 columns. All right, so it has 2 rows and 2 columns. 1 column and the next column. Okay, so that's a 2 by 2. All right. And so we call it a 2 by 2 matrix because it has 2 rows, 1 row, 2 rows, and 2 columns, 1 column, the next column. And so let's look at the other matrix. This matrix right here has 2 rows, 1 row, the next row, and it has 1 column. All right. So it has 2 rows and 1 column. So it has 2 rows. The second matrix has 2 rows and 1 column. Now, since these two numbers are equal, that means that multiplication between these two matrices are defined. And these two numbers right here, 2 by 1, tells us the resultant matrix that will be formed after we multiply these two matrices. And so what that means is that the matrix that we'll have would be a 2 by 1 matrix. Now, how does a 2 by 1 matrix look? Well, it looks like this. This will be, we'll have a 1 row and 1 column. Then you have a next row. We call it row 2, and then column 1. All right, so let me write that a little bit better than that. So this is going to be column 2. I'm sorry, column 1. And so what do we have? So this right here is a 2 by 1 matrix. It has 2 rows, 1 row, second row, and it has 1 column, 1 column. So this right here is going to give us the formula that's going to help us to multiply these two matrices. Because remember, our goal is to get a 2 by 1 matrix. So the first thing that we have to do, according to this formula, is we have to multiply row 1 by column 1. So this is row 1. We have to multiply that by column 1. Okay, so we have 2x, right? 2x multiplied by 2. Again, 2x, we have 2x minus 3, right? Multiplied by 2. Again, 2x minus 3 multiplied by 2. So that's what we have here. 2x minus 3 multiplied by 2. Then we say 4 multiplied by 6. So 4 multiplied by 6. Again, row 1, column 1. This row, right, multiplied by this column. 2x minus 3 multiplied by 2. And 4 multiplied by 6. That's what we have here. 2x minus 3 multiplied by 2 and 4 multiplied by 6. Next, according to the formula, we have to take row 2 multiplied by column 1. So you have to take this row, row 2 multiplied by column 1. It's going to be 18 multiplied by 2 and y multiplied by 6. Again, 18 multiplied by 2 and y multiplied by 6. That's what we have here. 18 multiplied by, negative 18 multiplied by 2 and y multiplied by 6. And that's what we have here. Negative 18 multiplied by 2 and y multiplied by 6. And so we set that equal to this matrix. Now we have to simplify what we have in here. First we distribute. We say 2 multiplied by 2x and 2 multiplied by negative 3. Now 2 multiplied by 2x gives us 4x and 2 multiplied by negative 3 is negative 6. And we put the plus sign. Now we have 4 times 6 and 4 times 6 is 24. Next we say negative 18 multiplied by 2 gives us negative 36. And 6 times y is simply 6y. And so we set that equal to this matrix. Next, we still have to simplify this some more because it still can be simplified. So let's do that. We have negative 6 plus 24, and negative 6 plus 24 is a positive 18. We bring down the negative 36 plus 6y, and so now, and then we also bring down the 4x. So now on the top, for row 1, column 1, we have 4x plus 18. And then for row 2, column 1, we have negative 36 plus 6y, and we set that equal to this matrix. Now, we cannot simplify this any further because 4x and 18 are unlike terms, and negative 36 and 6y are unlike terms, so we cannot add these, right? Now, what this is saying, what this equation is saying is that these two matrices are the same. Now, if these two matrices are these two matrices are equal. Now, if these two matrices are equal, based on this matrix equation, then that means that the corresponding entries must be equal, right? So two matrices are equal if and only if corresponding entries are equal. So this entry must be equal to this entry. So 4x plus 18 must be equal to 15. So let's write that down. 4x plus 18 must be equal to 15 because corresponding entries must be equal if the matrices are equal. And that also means, well, what that means is that we can use this equation to solve for x. And so let's send the 18 over the equal sign. It was a positive 18, but when we send it over, it becomes a negative 18. And so we have 4x is equal to 15 minus 18, and 15 minus 18 is negative 3. We divide both sides of this equation by 4. Then we cancel this with that. And so we have x is equal to negative 3 over 4. And that means that x is equal to negative 0.75 because negative 3 over 4 is negative 0.75. Now, what else do we know? We know that these two entries must be equal as well. So negative 36 plus 6y is equal to 0. And so negative 36 plus 6y is equal to 0. And that's the equation that we have. And we're going to use it to solve for y. First, we take negative 36 and we send it over the equal sign. It was a negative, but when we send it over, it becomes a positive. So what we have is 6y is equal to 0 plus 36. We add these two, and so we have 6y is equal to 36. We divide both sides of this equation by 6. We cancel this with that, and so we have that y is equal to 36 divided by 6. And 36 divided by 6 is definitely 6. So y is equal to 6. And so what we have is x is equal to negative 0.75, and y is equal to 6. And that's the answer to our question.